And welcome back. So let me run this module here and we'll see what we'll be doing on this video. So click on the shell. What happened to the okay, no, click on the module. There we go. Run module. Helps when I know what I'm doing. So here's our starting number, 10. This is adding by 5, this is subtracting by 5, this is multiplying by 5, dividing, and modular division. So basically, we're just going to make sure that you know what the commands are to do all these math problems. So let's just go in here into our Python 3 thing, and let's just start this up. So we have ourselves, our starting point, which is 10, right? So we're going to just make ourselves a print statement here because we need to make sure it shows up. So this is our starting number, and I'll maybe give it a couple spaces, and then of course I'll put myself a 10. So obviously this part is a string, this part is an integer. It'll default to integer if it's in blue, but just in case, we could always do int, and we can make sure that it's an integer. And of course, if by any chance you're getting stuff that's not integers when you think it should be, chances are you probably need to do something like this. So now I'll just make myself a couple of print statements here, and I'll give myself a new line just to space it out some. So this is adding 5. And of course, what did I forget to do? I forgot to put the quotation marks around it. There we go. Now it realizes that it's supposed to be a string. And I'll just simply put print, and now I'll just do, 10 plus 5. Easy enough, right? We know that the plus is adding. Even though the plus before, when we were using strings, was essentially combining two strings together, we are now using it as its actual function in mathematics. So I'll just copy and paste that. This time I'll say this is subtracting 5. And of course, instead of a plus, I need myself a minus. And we look at it. Yep, look, it's it's now subtracting 5. Yay. Okay. Well, obviously, we know how to multiply, right? Now, by the way, if anyone actually just gives me the x for multiplication, that's not how it would work. If I try to execute it, invalid syntax. It's not going to understand it. What you need is that little star key. So that one that is on, if you hold Shift and 8, at least on my keyboard it's Shift and 8, that'll give you that star. And now, of course, this is multiply 5. Yay. Whoops. Multiplying 5. This is, dividing ing, and we're gonna want this slash, not the one that we use for new lines or special characters inside text. So execute, and it decided to make it a float just in case. So you see how my integer wound up being a float. So let's just try something. Let's just say if I did int this divided by int this. Let's see if that would change something. No, it's still a float. So let's try if we wanted to. Let's see, can I have this operating symbol inside this while I do that? Can I do that and force it to not give me a little 2 there? Yes, I can. I can force it to put it as an integer with no decimal point, like this. Now, obviously, if I were to divide it by 3 or something, well, that's not going to evenly break through, so yeah, all the remainder is gone. But if I were to remove the int and remove the int, it's no longer a whole number. Now I can have a float, which will go all the way over there in these multiple lines like that. So know what type of end result you want. Now, the program defaults itself to a float with division because it goes and says, hey, wait a minute, we're going to have a remainder. We're going to have a decimal place. And of course, even if that decimal place is 0, it puts it right there. So just know that's what you're looking at when you have division. Now, this last one, modular division. This is something that you'll probably don't know what it means when I say modular division. So what is modular division? Modular division is essentially only going to care about that remainder. So it'll only show me the remainder of an equation. Why might you use something like this? Well, first off, let me just show you the symbol to use modular division. It's the percent sign. So 10 modular division 5. And our answer is 0 because there is no remainder. But of course, if I were to do it like, modular division 3, execute, we got a modular division of 1. There's 1 in the remainder. If I were to have 4, because 4, 8, there should be 2 in the remainder. Yep, there we go. So, I'll just hit 5 again, put it back to 0. So, why would we ever do something like modular division? Well, what happens if we have like a multiplayer game, and every single time it's someone else's turn, a counter goes up? Like here's player 1's turn, then player 2's turn, then player 3's turn, then player 4's turn, then player 5's turn, or whatever. So let's say we have 6 players. Or heck, let's just say we have 2 players. We have 2 players, player 1, player 2. So, and every time it counts up, it's going to go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Here's the problem, though. If you're just counting up integers, it's just going to go 1, 2, 3, 4, 5, 6, 7, 8. You need to translate which one of those numbers is for player 1 versus player 2. So if you just modular division by 2, then you know that every time there's a remainder, it's player 1's turn. Every time there's not a remainder, it's player 2's turn. Basically ensuring that even, odd, even, odd, even, odd, we have our way of deciding whose turn it is, and the computer will recognize that. So that's one potential use for modular division. But there we go. Once you have all these symbols working and everything prints out fine, go ahead and save it, submit it up through Moodle, and I'll see you on Thursday for the next few assignments.